What are SSL certificates? We'll begin our discussion by exploring how SSL certificates are used to secure communication and prove identity. SSL stands for Secure Socket Layer. An SSL certificate is a digital certificate that contains various data elements and encrypts information sent to the server using SSL technology. Since this definition can sound a bit confusing, let's simplify it using an example. Since an SSL certificate is a digital certificate, we can compare it with something most of us are likely familiar with, a traditional print certificate issued by some authority, perhaps a college or university. In this illustration, we can see that the certificate contains various fields. To start, we can see who has issued the certificate. In this example, XYZ University. Alternatively, if you went to another university, such as Harvard, the issuing authority would be Harvard. In the same context, an electronic certificate is also issued by an authority. By analyzing the data in a digital certificate, we can easily determine the issuing authority. Just like colleges and university certificates, SSL issuing authorities will have varying degrees of credibility. By conducting a simple internet search, we can see a large number of certificate authorities to choose from. The amount of information you need to provide in order to obtain a certificate will depend on the type of certificate you require. We'll discuss more on this later. On this Google search of SSL certificate authority, we can see a few well-known brands. We have DigiCert, GoDaddy, GlobalSign, Let's Encrypt, which we'll be working with quite a bit in this course. As you might guess, obtaining a certificate of graduation from Harvard would likely be harder than one issued by a local community college. The same is true for certificate authorities. Digital certificate authorities work the same way. It's up to the visitor of the web page to determine if they trust the body which has issued the certificate. Would you trust a certificate issued by Microsoft? Or on the contrary, would you trust a certificate issued by an unknown brand with a small internet footprint? Probably not. The next point of importance on a digital certificate is who it's issued to. Looking back at our traditional certificate, we can see it's issued to John Smith. A digital certificate, on the other hand, can be issued to a user, computer, device, or web page. Similar to a traditional certificate, the name on a digital certificate can be checked to make sure it's used by the intended recipient. If not, the certificate authority will reject the certificate. Another similarity between our traditional and digital certificate is the validity date. Some schools require you to take periodic exams to renew your certificate. A digital certificate also requires renewal. Using the methods we teach in subsequent lectures, you can easily automate this renewal process. Keep in mind that an SSL certificate cannot be used past its expiry date if it is not renewed with the issuing authority. A digital certificate also contains a public key, which we'll discuss later on. This is one unique attribute that a digital certificate has that a traditional certificate does not. A digital certificate also has a digital signature, which can be compared to the wax seal on a traditional certificate. The signature proves that the certificate came from a trusted source, and it's not a fake. Furthermore, the digital certificate can be used to determine if any data fields in the certificate have been altered. We will discuss digital signatures in more detail later in this course. So who decides if a certificate authority can be trusted? In order to understand that, it's important to recognize that all operating systems, mobile devices, and browsers operate authorized certificate authority membership programs. A certificate authority, also known as a CA, must be accepted as a member by complying with certain criteria. It's important to note that CAs can be both private companies and government organizations, but there are a relatively small number of them. As a general rule, the certificates issued by CAs that have been operational for a longer period of time are more highly trusted. This is because they have a higher ubiquity factor, which means their certificates are compatible with older browsers and older mobile devices. What are the different types of SSL certificates? There are several different types of certificates that CAs can issue. The right type of certificate depends on your individual objectives. For example, some organizations only need an SSL certificate to transmit confidential data securely through encryption. Others may want to show customers they've gone through a stringent vetting process to obtain their certificate to appear more legitimate. Extended Validation EV certificates. These types of certificates require the highest degree of vetting in order to obtain. They not only verify domain ownership, but also request a significant amount of information from the organization. The issuance process of an EV SSL certificate is defined in the EV guidelines, which was formally prescribed by the Certificate Authority or Browser Forum in 2007. This set of guidelines requires that CAs obtain the following information before issuance of an EV SSL certificate: verifying the legal, physical, and operational existence of the entity, verifying that the identity of the entity matches official records, verifying that the entity has the exclusive right to use the domain specified in the EV SSL certificate, verifying that the entity has properly authorized the issuance of the EV SSL certificate. EV SSL certificates can be obtained by all types of business organizations, including governmental, incorporated, and unincorporated. The organization validation certificate requires less stringent of a process to obtain. In this case, the CA still validates domain ownership and also requires some additional company information. One benefit of this type of certificate is the secure site seal that gives enhanced legitimacy to the domain name by adding the company name on the URL address bar. Domain validation SSL certificates. The domain validation certificate is likely the most popular type of certificate used. It's also the cheapest and easiest to obtain. In this course, we show you how to obtain and install one for free using a popular certificate authority known as Let's Encrypt. In this case, the CA validates the domain ownership but does not require additional information about the organization requesting the certificate. Despite this fact, all data is securely encrypted under the SSL certificate. How do SSL certificates work? Earlier, we introduced the digital signature. We know that the digital signature, among other important functions, determines if a certificate is authentic and unaltered. This can be accomplished because of the hash value assigned to the certificate. You can think of a hash value as a mathematical value for the certificate. The composition of a certificate is achieved by putting the certificate through a mathematical function to derive its value. To simplify this explanation, think of it as adding each byte in the certificate to obtain a value. The hash value is then put through another mathematical function using what's known as a private key to generate a digital signature. The digital signature is then added to the certificate. Once this process is complete, the digital signature can be used later to ensure the certificate is not fraudulent or altered. Earlier in this course, we introduced the term public key. A public key allows the flow of data to be encrypted that can only be decrypted using the private key. For example, if the issuing authority for a certificate was Google, you could use this certificate to encrypt data so that only Google could decrypt it. To check a certificate, the digital signature is put through a mathematical function using the public key. The result of this decryption sequence should be the original hash value. If so, the certificate is deemed to be authentic and unaltered. If the same hash value is not obtained, the certificate has likely been tampered with or corrupted. It's important to note that this decryption cycle is a one-way process. The resulting hash cannot be used to generate the original certificate or uncover the private key. The digital signature can be used for a variety of important tasks, such as checking the identity to make sure the domain name using the certificate matches what was intended by the certificate authority. For example, if we visit google.com, we can see the web page is encrypted using an SSL certificate. Our computer essentially downloads this certificate from this web host server and checks to make sure that the domain name matches the one on the certificate. This is an important feature because if the certificate was stolen and used by another domain, our computer would reject the certificate because the names do not match. Obtaining a certificate. Before we start installing our own SSL certificate, let's do a quick recap of the process using a visual illustration. Looking at this diagram, we can see at the top of the model, we have the certificate authority. For this example, we've used DigiCert. Let's say we wanted to obtain an SSL certificate for our domain name xyz.com. First, we'll need to request the certificate from DigiCert, which will allow us to encrypt data packets for users using our website. Before DigiCert will issue the certificate, it will need to verify that we own the domain name. Since we have not applied for an extended validation certificate, we don't have to provide information about our organization or company. Once our certificate is installed, you might be wondering what happens when a user tries to connect to our web page over HTTPS. When a web user types our domain name into their web browser, their computer will download the certificate. Once the certificate is downloaded, our system needs to confirm two important things. Is the certificate valid? And is the certificate legitimately issued by DigiCert? Our local computer can do this verification by default. This is because a number of certificates are installed on the computer when the operating system is installed. This includes a DigiCert certificate. Since the certificate is available on the local system, the system will trust any SSL certificates issued by DigiCert. As we mentioned earlier, once the certificate is downloaded, the digital signature in the certificate will be used to determine if the domain name on the certificates matches xyz.com. It will also be used to confirm that the certificate has not been tampered with. Since our browser must trust the certificate authority that issued the certificate, an error page will appear if it is issued by a source that is not known to our local computer. You may have seen this in the past. This page indicates that our Microsoft browser does not trust the issuer of the certificate downloaded from this web page. As we explained earlier, we'll be installing a certificate issued by Let's Encrypt. Let's Encrypt has revolutionized the way certificates are issued through the automation of several procedures. The current complex process of manual creation, validation, signing, installation, and renewal have been eliminated by Let's Encrypt. The best part is, a Let's Encrypt certificate is very secure and absolutely free. It provides TLS, Transport Layer Security encryption. The project is sponsored by several major tech names such as Google, Facebook, Cisco, Mozilla, and many more. In our demonstration, we will be installing the certificate on a DigitalOcean droplet. The droplet will be configured with Ubuntu 16.04 LTS, which is the latest version. Students often ask if Let's Encrypt can be installed on shared hosting accounts. Although this is possible, we strongly recommend moving away from shared hosting and into cloud hosting due to the flexibility and control you have over the server. Most shared hosting providers will also try to encourage you to use their expensive in-house SSL certificates, which can be very costly depending on the type of certificate you opt for. Since most cloud hosting providers now offer very cheap packages, there is very little reason not to switch. We'll need to take some steps before we get started on our project. First, we'll need to register a domain name. A certificate cannot be installed for a server with only a public IP address. The domain name can be purchased through any registrar of your choice. Once we have our domain name, we'll also need to create a droplet with DigitalOcean. The cost of a droplet is only a fraction of a cent per hour, 0.007 cents per hour at the time of this tutorial. They're also offering a free $10 credit. If you do not plan to keep your droplet running beyond this tutorial, you would likely only need it running for 30 to 45 minutes at most. The first thing we'll need to do before configuring our server is make sure that our name servers with our domain registrar point to DigitalOcean. Remember that your name servers must point to the servers that host your website. In this case, our server will be hosted with DigitalOcean. That's why we need to change them. If your name servers are already set to DigitalOcean, then you do not need to perform this change. Every domain registrar will have a domain name administration panel that allows you to change the name servers. If you are unsure how to do this for your registrar, send them a quick email and they should respond with instructions. We can also assist you if you've used a well-known registrar such as GoDaddy, HostGator, or Namecheap. There's other big names out there as well. Since the domain name I'll be using for this tutorial was registered with HostGator, I'll log into the HostGator admin panel where my name servers can be changed. I already have my username and password plugged in, so I'll click Login. From here, I'll click on the Domains tab. Now I'll click on the domain that I want to modify. And I can see the heading name servers here. So I'm going to click change because right now my name servers are pointed to another hosting provider, Linode. Now I'll just need to pull up the name servers for DigitalOcean. So the first one is ns1.digitalocean.com. The second is ns2.digitalocean.com and ns3.digitalocean.com. The fourth one we don't need, so I'm going to get rid of that. And I'm going to click the Save Name Servers button. Okay, so I'm just going to confirm that that change was applied. And we can see that the new name servers do in fact point to DigitalOcean. So with that done, I'm just going to log out. Okay, and we'll see you in the next lesson. Since we'll be creating and configuring a virtual server using DigitalOcean, you'll first need to sign up for an account by providing a valid email address and the login password you'd like to use. So here I am on the DigitalOcean website, and I'm just going to click on the sign up button. I'll enter my email address and a password. Okay, so once you've done that, it's going to send you an email, and you'll have to click a link inside that email to activate your account. And so once you've clicked that link, it's going to ask you for your billing information, and I'll be using PayPal. It asks for a small deposit. Remember that the server that we'll be using is only going to be active for about an hour, which would cost less than a penny. And so I'm just going to go ahead and do the $5 minimum. Okay, so as you can see, we're now ready to go. And we can start by creating a new droplet. So what I'm going to do is I'm just going to go back to the home screen. And we'll see a message saying we don't have any droplets. And in the next lesson, we'll start by creating our first droplet. Before we create our first droplet, we need to select the droplet's specifications. On the DigitalOcean website, you'll find their price list for different types of configurations. By default, the monthly pricing is selected. Let's go ahead and switch that over to hourly. We can see here that the smallest droplet is 0.007 cents per hour. That's the one we'll be using for this course. For the price, it offers fairly decent specifications. 512 megabytes of memory, 1 core processor, 20 gigabytes of SSD disk space, and 1 terabyte of transfer. Keep in mind that an SSL certificate can be installed on any one of these virtual server configurations. Now that we've decided on the specifications for our virtual server, we can go ahead and create it. Back in your DigitalOcean account, click the Create Droplet button. First, we'll need to select the operating system we want to use. Go ahead and select Ubuntu 16.04 64-bit. And if it's not there by default, just click on the drop-down menu, then you can select it from here. We'd already decided on the size of the droplet we wanted to create. We're going to go with the smallest one. So just click on it to activate it. Next, we'll need to select our data center region. And this is where your physical server will be located. So I'll go ahead and select the default, which is New York. And you can leave all the other options as default. Where it says choose a host name, just type in my server. That's what we'll call our server. Now it'll just take about a minute for the server to be created. Once you see the IP address appear, you know this server has been created. And you'll also see a little message here as well. One other important thing to note is as soon as your server is created, DigitalOcean will automatically send you a password and username for this server. And you'll need that for the next lecture. So just go ahead and check your email, make sure you did receive it. And we'll see you in the next lecture. In order to administer our newly created server and configure it, we'll need to use a console. If you're on a Mac system, you can open Terminal. If you're on a Windows system, you'll need to download a program called PuTTY. The download is free, and you can download the installation file from putty.org. From their home page, just click on this button, and then download either the 32-bit or 64-bit installation file. That'll depend on the system you're downloading it on. If you're on a 64-bit system, just download the 64-bit file. Once you've downloaded and installed PuTTY, go ahead and open it. With PuTTY open, we'll need to create a new site configuration. So first, I'm going to copy the IP address of this server, and I'm going to plug it into the host name field. Once you have your IP plugged in, just go ahead and click the Open button. Once you connect, you'll get a security alert. Just go ahead and click Yes. And we're going to log in as root user, so type in root. The next thing you'll need to do is pull up the password that DigitalOcean emailed you when you created the droplet. The initial password is going to be fairly lengthy, so be careful that you don't make any typos while plugging it in. An easy way to do it is just to copy the password and right-click. And although you don't see it, it's actually pasted the password in there, and I'm going to press enter. As soon as you log in, it's going to ask you to change the current password. So once again, I'm going to right-click to paste my password, my current password. And now it's asking me to enter a new password. So I'll just choose something that's easier to remember. Okay, so now we've reset our password and we can start with the server configuration. So we'll see you in the next lecture. Since our end goal is to host our website under an SSL certificate and deliver content over the HTTPS protocol, we need to configure our newly created virtual machine as a web server. This means we'll need to install services such as Apache, MySQL, PHP, and phpMyAdmin. I'm going to maximize my PuTTY window so I have more space to work with. And the first thing I'm going to do is I'm going to run the apt-get update command. Next, I'm going to run the apt-get upgrade command, and this is going to make sure that my server is up to date. Now with that done, we'll go ahead and install our services. And the services are all bundled together in what's known as LAMP stack. And that includes Apache, MySQL, and PHP. So the command for that is this apt-get install lamp-server, and just make sure to include that last symbol there at the end. This is just basic configuration. We need to create a password for the MySQL root user. And we'll need to repeat that password to confirm it. Okay, with LAMP server installed, we need to run this command to install the Apache 2 utilities. apt-get install Apache 2-utils. Now, if you're going to be administering your database with phpMyAdmin, you'll need to run this command as well. apt-get install phpMyAdmin. Just type in Y when prompted. When this dialog box appears, just select Apache 2 and press enter. When this dialog box appears, just choose the default option, click yes. Now we'll need to type in an application password for phpMyAdmin. And we'll repeat that password to confirm it. Okay, just a couple of more commands. First, you'll need to type this in. Now it's a fairly long one, so just make sure you don't make any, just type it in carefully. And press enter. And once that's complete, we just need to restart our Apache 2 service. So type in this command and press enter. Now that our server has been set up as a web server, we need to make sure that our web pages are accessible through our web browser. In order to do that, you're going to copy your web server's IP address and paste it into your browser and click enter. So this is the default page that loads after you initially install Apache on your machine. So we know that it is working. Another thing we know is that it's delivering the content over standard HTTP. So our connection right now is not secure. Our next goal in this course is to install an SSL certificate issued by certificate authority Let's Encrypt. And that's going to make sure that our content is delivered over HTTPS and not just standard HTTP. So we'll see you in the next lecture. So we know that we can access our web page by plugging in our IP address. But we also know that in order to encrypt our connection using HTTPS, we need to configure it so that we can plug in our domain name to access our web page. That brings us to the next step in this process. We need to make sure our domain name resolves to our newly created server. You might recall that we'd already pointed our name servers with our registrar to DigitalOcean in a previous lecture. This means all we need to do now is configure our DNS settings in the DigitalOcean admin panel so that our domain resolves to the right IP address. In order to do this, I'm going to go back to my DigitalOcean dashboard and click on the networking link. Here we can add the domain we'd like to use. So I'm going to plug in my domain and click Add Domain. To make sure that our domain name points to our IP address, we'll need to add an A record. Just type in the @ sign here. And in this drop-down menu, you'll get a list of your droplets. Remember that we named our server My Server. So we want our domain name to resolve to this server. So I'm going to go ahead and select it. And I'm going to click Create Record. So this means anytime somebody types in uxl.com, it's going to direct to our IP address. We also want to make sure that when somebody types in www in front of our domain name, that it also resolves to uxl.com. Now for that, we'll go ahead and add a CNAME record. So type in www. Now here, just type in the @ sign and click Create Record. Okay, now anytime the www is plugged in front of our domain, it'll automatically set it to uxl.com. With your DNS settings created, you should now be able to plug in your domain name instead of the IP address. And you can see that it now pulls up the default Apache page. Just in case this doesn't work for you, the most likely reason is you've only recently updated your name servers with your registrar. So anytime you update your name servers, it could take 24 to 48 hours for that change to take effect. So if your domain name does not resolve to your IP address after you've done this last step, just wait 24 to 48 hours and check back. One step we'll need to perform before installing our SSL certificate is to add our IP address and domain name to the hosts file of the server and also update our time and date settings. Both of these steps are relatively easy to do, but also very important. After we install our Let's Encrypt certificate, we will be setting up an automated script known as a cron job to renew our certificate periodically. We want to make sure our certificates are renewed on the correct dates and times based on the server's settings. So I'm going to open up PuTTY again. Since I hadn't closed the window, I've just expanded it again. If you've closed it, you'll need to reconnect to your server before you continue. So the first step, type in nano etc/hosts. Now, since I'm connected to this server in another location as well, I've gotten a message asking me if I want to continue. You probably won't get this, so I'm just going to type in yes. Now, you're going to keep tapping the down arrow key until you get to this blank space here and just press enter. Now, I'm going to type in my IP address and then press tab and then type in my domain name. Okay, and that's the only change we need to make to the hosts file. So I'm going to exit. To exit, you press Control X. It's going to ask if you want to save the changes you just made. Type in Y and press enter. Now we're going to change the server's date and time settings. So to do that, plug in this command here. Press enter. So we're going to select the geographic area first. I'll select US. And the region. So I'm going to select Eastern and press OK. And that's it. So in the next step, we can go ahead and install the certificate. With our server and domain settings configured, we can now go ahead and install our SSL certificate using Let's Encrypt. The first step in the process is to install the Let's Encrypt client. To do so, type in the following. Once you've typed in this command, go ahead and press enter. When prompted, type in Y and press enter. With our client installed, we can now set up the SSL certificate for our specified domain name. To do that, type in the following command. Make sure you replace uxl.com with your domain name. You can see here that we now have the installation assistant, which will present a series of prompts throughout this process. So the first is asking for an email address. The next is to agree to the terms of service, so I'll press enter. In the next step, it's going to ask us if HTTPS is required or optional. It's always a good idea for your users to access your web page over HTTPS. Not only does it secure the data, but it's also an excellent way of optimizing your website for search engines, especially Google. You'll notice you get much higher rankings when you're delivering content over HTTPS. So I'll select the second one, secure, make all requests redirect to secure HTTPS access, and press enter. So it now says, congratulations, you've successfully enabled HTTPS at your domain. So I'll go ahead and press enter again. So we'll just go ahead and confirm that we can now access our web page over HTTPS. And so there it is. You can see that we've now have the secure label next to our domain name, and the content is delivered over HTTPS. If I were to type in HTTP you'll notice that when I type in the HTTP uxl.com, it automatically does redirect to HTTPS. In the next lecture, we'll show you how to verify the status of your SSL certificate on the SSL Labs website. With your SSL certificate installed, it's a good idea to run periodic checks on the status of your certificate. Remember that a certificate which is canceled by the certificate authority will lead to warning labels attached to your website when a user tries to access it. To check the status, type in the following URL, replacing uxl.com with your base domain. On this page, you can see a full diagnostic of your domain rating based on several key factors such as the cipher strength and certificate status. The table below also contains some very important information. First, you can see your domain name listed under common names. Secondly, we can see the validity date. This certificate was issued today, Tuesday, March 7th, and expires on Monday, June 5th. It's very important to renew your certificate before it expires. In the next lesson, we'll show you how to set up a cron job to automatically renew your certificate at specified time intervals. We can also see here that this key uses a 2048-bit RSA encryption. This is considered excellent. The issuer of the certificate is Let's Encrypt Certificate Authority. And you can see that there's volumes of other information as well. Some of this information might be important to you. For full documentation, you can visit the documentation page by clicking this link. The next step in the process is making sure that all variations of our domain name lead the user to our base domain over the HTTPS protocol. At the moment, if we type in www.uxl.com, you'll notice that it's not directing the user to the HTTPS version of the site. The same is true if we were to plug in our IP address. This should automatically redirect the user to HTTPS followed by our base domain, which in this case is uxl.com. And lastly, if we were to type in uxl.com, again, it's not taking us to the secure site. Okay, so all variations should point to HTTPS and then our base domain. So let's go ahead and get started. I'm back in PuTTY, so if you had closed it down, you will need to reconnect to your server. The first thing we'll need to do is create a .htaccess file. When configured correctly, this file tells Apache where all URL variations should be directed. So the first command we need to type in is cd/var www and then /html. I accidentally put an extra W there. Now I'm just going to use the ls command to show you what files are in this directory. Right now we only have the index.html file. Now this is the page that loads when we visit our website. It's the default Apache page when Apache is first installed. So this page here, this is the index.html file that we're seeing in our web root folder. So when you develop your web page, you would ultimately replace this index.html file with whatever your home page would be for your website. So this is the same folder that'll contain our .htaccess file. To create it, type in nano.htaccess and press enter. So we'll go ahead and create the content for this file, and it's a set of commands. So I'll just enter them in one by one, each on a separate line. So the first condition here will redirect the user. If they use the www prefix, it'll redirect them to HTTPS and then our base domain. If they type in the IP address, that would also redirect them to HTTPS and then the base domain. And lastly, any attempt to access the domain over HTTP will redirect them to the HTTPS version. So those are all the three conditions we want. And I'm going to save this file by pressing Ctrl X, typing in Y, and then enter to save. Just before I hit save, I'm just going to confirm that I haven't made any mistakes. And everything looks okay. The next thing we need to do is instruct Apache to read our .htaccess file anytime our website is accessed. And to do so, we'll need to modify an important configuration file. So just type in this command here to open the Apache 2 configuration file in our Nano text editor. And once this file opens, keep pressing the down arrow key on your keyboard. And scroll all the way down. When you see the directory text here, you're going to replace allow override none to allow override all. And this is going to allow Apache to read our .htaccess file. So I'm going to exit, Ctrl X, type in Y to save, and press enter. Okay, the last thing we need to do is just restart Apache to make sure that these changes do take effect. So type in service Apache 2 restart. Now before we test this in our web browser, just make sure you clear your web browser's cache to make sure you're not viewing older versions of your web page. And I'll do the same. Okay, so there we go. I've cleared the cache. And now we'll just go ahead and test each variation again. So we'll start with www.uxl.com. Okay, so that works. It You can see it redirects to the HTTPS version. Next, we'll try justuxl.com. And that redirects to HTTPS as well. And I'll just need to pull up my IP address again. So I'm going to paste my IP address here. And that also directs the user to the HTTPS version of our site. Okay, so with that completed, the last step will be to set up a cron job to make sure that our SSL certificate automatically renews at specified intervals of time. So we'll see you in the next lecture. The last step in this process is to make sure our SSL certificate is periodically renewed so that it doesn't expire. To do this, we'll be setting up a cron job in our cron tab, which is available as part of Ubuntu. If you are new to this process, cron tab is a list of commands that you'd like to run on a regular schedule. You can use cron tab for many different things. In this case, we'll set up a cron job in our cron tab to execute a command to renew our SSL certificate with our certificate authority. So let's go ahead and get started. Back in PuTTY, with my connection still active, I'll launch the cron tab with the following command. I'll press enter. It's going to ask me which text editor I want to use. I'll go ahead and choose Nano, which is number 2. Now with the cron tab open, I'm going to create the following cron job. I'm just going to tap the down arrow key and I'm going to enter it right here. So this cron job will attempt to renew our certificate every Monday at 3:30 a.m. And this diagram shows an illustration of what each asterisk means in the cron job format when replaced with a value. Each time this cron job executes, the result is going to be outputted in this log file, le-renew.log, and that's going to be located in the var folder. So you can see that the actual command is let's encrypt renew, and that's what's going to renew the certificate. So I'll save this by pressing Ctrl X and then entering Y when prompted, and then enter to save. And so with our cron job created, we no longer have to worry about our certificate expiring. Now I'm going to go ahead and close down PuTTY. And we'll see you in the next lecture.